All
Hey,
right.
go ahead.
My name's Luke Walling, and I'm here with Luis Ruiz, and this is ECE 536, our final project.
Hello, everybody.
Um, well, to start off, the goal of our project is to create a ARM v7 project, and the goal of the project is to create a multi-threaded program and switch between the three threads. The first thread that we are trying to design is to display a rotating circle on the 7-segment display that will simply take one of the sections of the display and circle it around the outside. The second thread will be to display a continuously incrementing variable. The way we have it set up is that the variable will be incremented every single time that we have the circle rotate once around the 7-segment display, and those will run at the same time. And the third thread will be to check the value of a push button, and the goal is to use that push button to reset the counting variable that is counting from thread 2. So while the circle is rotating, if you press the button, the counter will reset back down to 0. Um, we have two different ways that this was to be implemented. The first way is to do the time-based context switching, and the second way is the asynchronous context switching. In order to do the asynchronous, all we did is designed it in a way to basically run one thread at a time and cycle between the threads automatically. And with the time-based context switching, we have it run the certain thread for a certain amount of time. And then after that time has elapsed, we switch to the next thread.
So this is our explanation of our basic approach. So we essentially first started by separating each function, each thread as its own separate function. We wanted to make sure that that each thread can work independently of each other, because that's essentially what threads are, working things simultaneously, but being able to also interact, possibly if that's a case, to work with each other, or just to be able to have multiple things working at the same time. So we first began with thread one of the rotating, it's essentially a segment on the 7-segment display that would circle around. We just wanted to make sure that it forms a loop, and every time that loop starts, it goes from the top and it scrolls down, kind of making a 0 all the way around. Thread two is just a simple increment counter. We just wanted to make sure that that thread or that function can increase once every time it enters. We made sure that it was 2 digits, so it essentially can count from to 100, from 00 to 99. And once it reaches 99, it resets back down to 00. And thread three is essentially to make sure that whenever a push button is pressed, that there is an interrupt. And when it enters, when it starts to check that interrupt, it would actually go ahead and reset the counter. It's basically having a global variable that can be reset back down to 0. We did kind of combine two and three together, in the sense that the variables in two can be changed in thread three, which essentially means a global variable. So whenever a push button is pressed, it would then go and reset that global variable down to 0. So when it starts to thread two, starts counting again, it would then start from 0 and continue going up. We also created a thread controller, which controls all threads, and depending on the flag, which one it's supposed to be running. Um, and we also created a timer controller, which then actually controls how long we should wait. If we didn't have this timer controller, it's very hard to tell with the naked eye exactly which thread is working on which one, and we won't be able to see like a nice flow on the 7-segment display.
Okay, so this is a flow chart starting off with the async design. Like Luis said, we originally began by creating each of the three threads separately. You can see there at the bottom. Um, Once we had each of the threads working, we designed this method for having them communicate with each other and work in order. The main part of this is the thread controller that Luis mentioned. Um, as we go through the different threads, if you look at thread one in the bottom left, thread one, once it's called, will shift the line in the second 7 segment display to make it look like a part of the circle has moved. Um, then it checks if the circle has finished moving, um, as in the part has moved all the way around to complete one full rotation of the circle. If not, that top line in the left says no, and we keep mode one as the next thread. We head back to the thread controller. The thread controller checks which thread we run next again and goes on to thread one. After thread one has ran enough times to complete a circle rotation, we are setting thread two to be the next thread. Then we go down to thread two in the bottom right. Once thread two is finished running, we increment a counter. That counter basically means that we've counted one since we finished one revolution of the circle. Then we go to thread one again next to begin another revolution of the circle. During all of that, like Louis said, we kind of combined thread three and two, where if an interrupt is activated, we jump to thread three, which simply resets the counter variable that is being used in thread two. And then thread two sends us back to the thread controller and we start thread one again that way. Um, all in all, this design makes it so that after we've designed the three threads separately, we can combine them and create the thread controller to make them communicate with each other and run the way that we're expecting them to run one after another. This flowchart is our modification using the time-based method. As you can see, we've added the timer controller at the top. Most of this design is the same. However, the one thing that we've added is that anytime we turn to the thread controller, we pass through the timer controller first. The timer controller simply sets the amount of time that we want to wait for after each thread is run. Once we wait for that amount of time, then we head back to the thread controller again. Same thing happens if we receive the interrupt. We run thread three, which resets the counter, and thread one will still repeat until it's completed a circle. The goal of adding the timer controller here is that during the waiting period, it gives you enough time for visually to see the update. If we don't have the timer controller, again, like Louis said, you wouldn't be able to see it with the naked eye because everything would be changing so fast. So by giving it a small period of time to wait in between, you can actually see the segment of the circle move. And while it's still pretty quick, it will look like the circle is moving around in a circle. And then you can see the number of thread two update every time a circle is completed. Um, so here we move on to thread one function, which is the circle. Uh, Basically, here is a small snippet of code on the right side. The main objective of this was to move the segment each time that this function is called. So we begin by setting the thread number, which is an update for knowing what thread we're running. We create the first segment of the circle, so it starts at the top, and then we left shift, which moves the line segment to the position around the circle where it's supposed to go next every time this thread is run. Um, the second left shift there simply moves the thread number to the third display, so we know what thread we're running visually. The OR makes the thread number basically with the segment of the circle. We're updating the display every time this thread is run, so you can, again, visually see where the location of the circle is. And then we're incrementing the variable that's actually used for the shifting. The goal of that variable is that when we come back to thread one, then we know, okay, where is the location of that first segment of the circle? And we can update it to the correct position each time. Once that variable has been incremented enough that we've gone all the way around the circle, then we know that thread one can stop running. Otherwise, thread one will continue running. The thread controller will send us back to this thread every time until the circle is completed. And then at the very end of this function, we break to the start timer function, which essentially begins the timer controller. Um, that timer controller is only used in the timer mode. If we are not doing the timer mode, then we would simply return to the thread controller instead of the timer controller.
Here are snippets for thread 2 and 3. Well, it's actually just for thread 2, but thread 3 would also be essentially an interrupt, which then resets it. But going for thread 2 at the top, it's essentially we set R7 as a variable to kind of show the segments to display a number 2 on the display. And we also shifted so that way, as Luke mentioned earlier, for the third segment, starting from that base address. We then create a number on the display um, using an array relative to the number of segments that are needed to be activated or turned on so it could show a number that we're looking for. This array is set at the bottom, and the load essentially finds the address location of that address. So in theory, and it actually works, let's say the first address or the first element in that array would be the specific address for that. And since it's the first one and the increment starts at 0, you essentially get that first set of that element is displayed as a 0. And then as you increase it every time, it then goes to the second address, which would be number 1, and so forth, all the way up until 9. Um, we also have a check to make sure that once it reaches 9, the second display ends up incrementing by 1. So that way it starts with 0, 0, and every time it increases once it reaches 9, and then resets itself. We also have 1 so that way once both reach 99, it actually resets both of them back down to 0. Um, and as Luke mentioned before, we also have the timer included there so that we can start before it actually goes right back into the main thread. Otherwise, when we don't use the timer, we're just setting up to return straight back to the thread without having to wait for anything. And here is our main thread controller. We initialize everything to 0, and whenever we're at the top of this thread, it would also reset it to 0. And as you can see, the second line, we branch off into thread 1. As we come back, our 8 is essentially the register that's a global variable. And we want to make sure that if you look at the 7-segment display, the top is 0. The 2 lights on the right are 1 and 2. Bottom is 3, 4, 5. And then the middle one is 6. We want to make sure that it completes the whole circle without going to the middle. So that's why we want to compare if our 8 has reached 6. And we'll continue going. But once it does reach 6, we want to reset it back to 0 and move on to thread 2. And that is essentially how we get to decide when does it actually continue going to thread 1 or thread 2 by deciding where on the rotating segmented display to complete a full circle. And we also continue jumping back to the beginning of the thread once everything has been set up. And we do that move R9, R9 just to make sure that we did have some issues with clobbering registers. So as long as we get to continuously move the correct registers and replacing them, we kind of avoided that, but there were still some issues that we'll explain later on. But we also wanted to make sure that we keep this thread going continuously until there is an interrupt, which then resets, which is first interrupted through the push button, which then resets the counter.
Okay, so here we have the timer controller. Um, as mentioned before, if we are not using the timer controller, the system will simply run too fast to be able to see visually. So we are using this timer mode in order to slow the system enough just to see what happens while looking at the 7-segment display. It begins by using the start timer function, which, as you remember, is called after running thread 1 and thread 2. The start timer function simply sets the values for how long we want to wait. Those numbers you can change depending on how fast or slow you want the system to run. And then it begins counting down. Once we begin counting down, it moves on to the wait for timer section. The wait for timer section keeps us stuck in that loop and simply keeps looping through it until the timer reaches 0. Once the timer has reached 0, it uses an interrupt to break us out of the wait for timer. And as you can see there, it jumps to the timer interrupt section. Once we've jumped to the timer interrupt section, all it does is resets that interrupt bit. So it's ready to go for the next time we need to use the timer, and then returns us to the thread controller. Um, all of that happens basically after we set the value for how long we want it to count down. The timer interrupt will take over once that counter has reached 0, and that means that the system has waited the amount of time that you've specified in the start timer section before moving on to the next thread. That allows us time to visually see the 7-segment display update with the new information. That way you can understand what's happening while the threads are running, as well as see what thread number we're on while it's running, because we are displaying that on the 7-segment display as well. Um, So here's some of the other important functionality, extra things that we've added in for ease of use and for redundancy. In the beginning of the system, there's a section of code where we are setting a lot of the register's initial values in order to use them later on in the system. This is pretty standard for most ARM7 designs. Um, so we are doing it here as well. Like we said, thread 3 interrupts the system. We have the interrupt set up as well in the beginning of the system for that. So whenever, like Louis said, whenever the push button is pressed, that will reset the counter from thread 2. We have the increment 10 function, which basically increments the tens place value when we reach 9 in the ones place. It simply allows us to count past 9 and count into a double-digit number. Um, since we're counting double-digit numbers, we also included the over 100 function, which once we reach number 99 on the 7-segment display, we don't have a third digit to display, and that can cause some errors. So once we increment after we're at 99, it just resets the counter back to 0. Um, and we can also disable the timer after thread 2. Um, this can be done for the purpose of uh, visual appeal mostly. Thread 1 will continue to update in a circle with a slight pause from the timer in between each segment of that. So visually you can see the circle moving, but without a pause after thread 2, what happens is that the counter for counting the number of circles updates immediately. So while you'll see that number increment, the fraction of a second when you would see what thread we're running says thread 2. Usually you won't be able to see that with your eye. However, the circle will continue to rotate smoothly. If you have the timer after thread 2, the circle will pause for a fraction of a second while thread 2 updates the value. And that pause will be the length of how long you set the timer for. Basically smooths out the animation of the circle and updates the counter immediately while that circle is spinning.
So here we have the benefits of timer over the base architecture. Um, Essentially, when you have a timer set, you can determine exactly when the switches are to occur. It gives the programmer a little more control over exactly when these switches happen versus arbitrarily whenever the hardware um, finishes its cycle. For every cycle, it'll just keep going on forever. And at least when we have the timer on, we're able to kind of control exactly when we want to have these threads occur. We're able to also, as we mentioned previously, that we could actually slow it down and actually see the 7 segment display go down through a circle, and we kind of held it to a point where it's almost like every second you actually ticks up once, and we circle around that first 7 segment display completely within a second. Um, and and we could also this also works for scalability. So in case we do want to add more threads, or even something to make sure something gets checked on a little more regularly, we could also set up interval checks in case we do want to scale this and add more threads. We could essentially control to make sure, hey, we want to make this thread work for this long before we move on to the next one. And here we have a working of our project. So here we have built the code and we've compiled it, and now we're going to have it running. And here we have the timer base. Um, we also set it up to make sure that doesn't matter which buttons get pressed, whether they're all at the same time or one at a time, you could actually see them working. And here, as we press 1 or 0, we turn it off, you saw a 3 flash for a quick second. So this actually kind of works out the best way. We got this working by also figuring out some issues with clobbering the registers, because clobbering is essentially trying to keep up the integrity of these registers as they're being used in other threads and other functions. Um, but we were really happy with the result that we were able to show, the thread 1 being able to circle, and whenever it does increment by 1, you saw it flash to thread 2 real quickly. Um, and whenever there is a push button press, whether they're all at the same time or doesn't matter, 0 through 3, you could kind of see really quickly that it's a quick interrupt. It changes everything down to 0 and it resets essentially the whole code from working back again.
So some of the problems we had along the way, like we said before, thread three to us wasn't really its own thread. If we were to design it as its own thread, then you would have to wait for threads one and two to finish every time before thread three is ran. And then only while thread three is running will it check if a push button is pressed. So we thought that a better solution to that would be that we have thread three behave as an active interrupt, um, and basically allow that to occur anytime and switch resetting that counter um, anytime that the push button is pressed. Um, the second problem that we again already mentioned before was that the asynchronous mode moves too fast for the eye to see what happens visually. Basically, adding that timer mode allows us to see what happens when the system is slowed down. Before we designed the uh, timer controller, we were simply stepping through um, the system, uh, one line at a time, and that allowed us to actually see what was happening. And that's how we solved that problem before designing the timer controller. Uh, when we first designed timer controller, however, that was also running too fast to see. So the simple solution to that was we created a larger variable that allowed us to actually control the time that we were using in the timer. Um, That way we could slow it enough to see what's happening. It also makes the code more customizable. You can set the time to whatever you want to make it run as fast or as slow as you want. And the last problem we encountered was the register clobbering. This happened a lot. Being able to preserve the register when changing them basically just needs to be worked on more. But in the meantime, while we were testing our design, there is a setting that we used in CPU later that could basically turn off the error that happens when a register is clobbered. Um, the register clobbering didn't break the function of our design at all. It was simply something that acted as a breakpoint and errored out. So disabling that error allowed us to run the design and test it.
And for our conclusions and results, we essentially we were kind of happy with our end result. We got one main thread, which is the controller, and from there, all the other threads are connected to and are controlled to see which one should be displayed. Each thread does run to completion, and the main control which one gets to work on next, given the flags from the previous threads. Um, we do have, as Luke mentioned, our clobbering situation. We do need to work on that to make sure that we can maintain the register integrity of each one that does get clobbered. Majority of the time, this happened because we either didn't push certain registers to the stack to try to keep them from being updated within one register while within a one thread before another one gets used. So that could be an issue, but our program overall was pretty simple. So even though the clobbering did happen, as Luke mentioned, it didn't affect our overall result. Um, and I think overall, being on a time-based architecture does allow for more user control or programmer control. And it could be used to scale predictability to make sure that, hey, this actually works to the way that we want to. Because if it is asynchronous, it happens too fast. The only way to make sure that it does is through stepping through each thread one by one, and that could be cumbersome. So if we slow it down and make sure that, hey, before each thread starts, we can actually see where it's at. Um, Even if we increase that variable to be very long, we could at least wait to see before the next thread starts and which one will follow through next. And that is our presentation. We were pretty well pleased with how it all turned out.
Yep. Thanks, Luis.
Thank you, Luke.